Student Companion Exemplar 1. Alright, so Exemplar 1 talks mainly about literal equations. Okay, so the first question says solve the equation A equal PBH. Okay, and says you're solving for B. So the aim is to get B all by itself. Okay, so firstly we locate B. B is on the right side of our equation. To get the B all by itself, I need to realize what B and H are doing to each other. Well, when you don't see an operator in between, you assume you're multiplying. So to get B all by itself, you would divide by H. So your B is equal to A over H. Okay? And that is the result. Okay? So the answer would be B is equal to A over H. Okay? So the next one. So the next one says solve the equation A equal H parentheses B1 plus B2 over 2, and we're solving for B1, okay? So the aim is to get B1 all by itself, okay? So the first thing we're going to need to do, guys, is get rid of anything that looks like a fraction, okay? So here, we don't see anything that, we see something that looks like a fraction, we see the 2 as a denominator. To get rid of fractions, you multiply. So I would multiply by 2, because a fraction is like you're dividing by that number. Opposite of divide is multiply, okay? So now we would have 2a is equal to h parentheses b1 plus b2, because the multiply cancels that divide, okay? So now I need to get rid of the h, because the h is on the outside of the parentheses, okay? And it's being multiplied by the parentheses. So to get rid of that h, you would divide by h on both sides of the equations. That would get canceled, and we would have 2a over h is equal to b1 plus b2, okay? So the final step now would be to get b2, or rather b1 all by itself by getting rid of b2. To get rid of b2, I would need to do the opposite of adding b2, which is subtracting b2, okay? So my answer is going to be, so the subtracting b2 cancels, we'd have b1 is equal to 2a over h minus b2. Okay, just like that. Okay, so the next question. So the next question says, describe the steps you would take to solve the given literal equation for m as shown below. Okay, so we're going to try to solve this and describe each step in solving. Okay, so we have t is equal to 2 pi square root m over k. Okay, so the first step, again, we're trying to isolate m. All right, so to get m all by itself, I would need to firstly get rid of the 2 pi that's in front of the square root, okay? So to get rid of that 2 pi that's being multiplying, you would divide. So I divide by 2 pi, divide by 2 pi on the other side. So the divide cancels the multiply, okay? And we would now have t over 2 pi is equal to the square root of m over k, all right? So the first step we did was divide, all right? So the first step we did was division, okay? So now we're going to do the next step, guys, all right, which is to get rid of the square root. So you can think about the square root like a house, and we're trapped, the m is trapped in the house, okay? So to get rid of the square root, I need to square both sides of the equations. So I would square this, and I would square all of that, okay? So the square cancels the square root, okay? So I'm left with t squared will be t squared over, so I'm going to square each of these things. So 2 squared is 2 times 2, which is 4. Pi squared is just pi squared, okay? Is equal to, so again, the square root goes away, and I'm left with m over k, all right? So what I did right there was called the squared property, all right? So what I did second was squared property, okay? So after I squared, okay, I need to now get m all by itself, so I need to get rid of that fraction. To get rid of that fraction, we do the opposite of divide, which is multiply. So I multiply both sides by k. So the multiply cancels the divide. So I'm left with m is equal to k times t squared is just k t squared, because they're not like terms, we can't change them. We just write kt squared over 4 pi. Oh, this should have a squared, because again, we squared the pi also. Okay, so again, that final step we did was what? We multiplied. Okay, so the third step, we multiplied. All right, or the multiplication property. Okay, so again, guys, just like that. Okay, so the next question. So the next question says the velocity of an object moving in one dimension is given by the formula v is equal to u plus at, where u is the initial velocity, a is acceleration, t is time. Solve this equation for a. So again, all I want you to do, guys, is just rearrange this equation and get a all by itself. Okay, so the first thing we need to do is get rid of the u. The reason we would get rid of the u first is because the u is single, it's all by itself, and I can't break up the couple until I get rid of the single person. So I need to subtract u on the other side. That gets cancelled, and we'd have v minus u, because again, you can't subtract them, they're not the same letters, is equal to at. The a and t are being multiplied by each other, so to get rid of multiply, you would, divide by that t. Okay, you can't divide by a, because if you divide by a, you would not be solving for a. Okay, so v minus u all divided by t is equal to your a. Now a is all by itself. This is my result. Okay, so the answer would be D. So that one right there. Okay, so what about the next one? So the next one says solve y equal ax squared plus c for x. Okay, so again, guys, you're trying to get x all by itself. Okay, so the aim is that we need to first get rid of the single person. All right, I can't break up the couple until I get rid of the single person. So to get rid of an adding c, you would subtract c on both sides of the equations. So we'd have y minus c is equal to ax squared. All right, so again, we're trying to get x all by itself, so I need to break up this couple by dividing by a, dividing by a. I could not divide by x because that would mean that I'm not solving for x. Okay, so we'd have y minus c all divided by a, okay, is equal to x squared. The final step to get x all by itself, because again, x squared is different from x. So to get x, I would need to get rid of the squared. To get rid of the squared, you do the opposite of squared, which is square root. So I square root both sides of the equations. The square root cancels the squared, or the squared cancels the square root. So we'd have the square root of y minus c all over a is equal to x. All right? When you take the square root of something, you're always supposed to put a plus or minus sign in front of it. All right? So the answer looks like it would be B. All right? So let's try the next one. Okay? So the next one says, check all equations that are equivalent. Okay? So what I'm going to do, guys, is that I'm going to try to expand everything to see what could be equivalent. So here we could possibly expand, because again, we have 180 m minus 2. But guys, let's look at all of these answers. This says a equal, but this says n equal, n equal, n equal. So this is the only thing that says a equal. So let's actually make this look like an n equal also. So what I'm going to do is that this equation, I'm going to try to get it where n is all by itself. So to do that, I need to firstly get rid of the 180. Because again, the 180 is on the outside of the parentheses and it's being multiplied, so I need to get rid of that first. Okay? Think about it like a bodyguard and it's stopping you from getting inside of the parentheses. So to get rid of that bodyguard, we would divide by 180. Okay? The divide cancels the multiply, so we have a over 180 is equal to n minus 2. So the final step to get n all by itself is to get rid of a minus 2. The opposite of minus 2 is adding 2. So I add 2 to both sides of the equations. The 2 cancels, so we'd have a over 180 plus 2 is equal to n. All right. You can't add the 2 to the 180 because this 180 is a fraction. This right here, this 2 is a whole number. So I can't just add this 2 to 180. All right. What I could, however, do is that I could write this denominator as a 1, get a common denominator by doing the butterfly method. So I multiply these two, I get 180. I cross multiply these two, I get A. I cross multiply these two, I get 360. And then what am I doing? I am adding. So this is called the butterfly method, all right, is equal to n, okay? So that's how you add or subtract fractions, the butterfly method. So again, guys, this is what the final result could look like, okay? So which one looks like this? So this technically looks like this right here, all right? But there was also something that was also equivalent. Yup, this right here, all right? So those are the three things that would be equivalent, okay? So let's try the next one. So the next one says we're solving for W, okay? But here we have two sets of fractions. But the aim is to solve for what? W. So my aim is to get this W right here all by itself. So the first thing we're going to do is that we're going to get rid of what we don't like in algebra, which is fractions. To get rid of a fraction, you multiply. So I multiply both sides by 2z. So I can get rid of that fraction. I don't need to get rid of this fraction over here because, again, W is already on this side. It's already kind of isolated, so I don't need to do anything to this fraction. I just need to move all these things to the other side. Okay? So now I have, so again, you now multiply 2z by each of these terms. So I multiply by this and this. 2z times 2x, 2 times 2 is 4. Z times x is xz or zx, okay? 2z times negative 1, 2 times negative 1 is negative 2, and I just bring the z along, okay? All divided by y is equal to, so again, this canceled, w plus 2. So my final step would be to get rid of the plus 2 by subtracting 2 on both sides of the equations. That gets canceled, and my w is equal to 4xz or zx minus 2z all over y minus 2. Okay? I can't subtract 2 from any of these terms, and this minus 2 is not on top of the fraction. It's all by itself. Okay? So again, guys, just like that. Okay? So the answer that looks like this one, so no, because I don't have the minus 2. No, yep, this one. Okay, so let's do the last question. So the last question says that shown below are the steps a student took to solve the simple interest formula A equal 1 plus RT. Our aim is to solve for R. Explain the algebraic error in the student's work, then state how the equation R equal parentheses A minus P all over T can be modified to produce the correct result. So I need to make sure that this gives me the correct result, and I started here, okay? So I think there should be technically a P right in front, okay? So if I have A equal P, parentheses 1 plus RT, and my aim is to get R all by itself, the first thing I would need to do is get rid of the P. To get rid of that multiplying by P, I would divide by P, all right, on both sides of my equations, all right? That cancels out, so now I have A over P is equal to 1 plus RT, okay? So here, guys, from step 1 to step 2, did they do that? No. So I think that's where the error might have happened, okay? So again, we're just going to complete it, okay? So the next thing we're going to need to do, guys, is to get rid of the adding one, the positive one. Okay, to get rid of that positive 1, I would subtract 1 on both sides of the equations. That gets canceled. I'm going to write the rest over here. A over P minus 1 is equal to RT. And then the final step is to get rid of this T. So we would divide by that T. That's how we break up the multiply. And then we'll divide all of this by T. Dividing by something is the same as multiplying by something called the reciprocal. So again, I would do a over p minus 1, and technically I could multiply this by something called the reciprocal. So I can multiply this by 1 over t, okay, is equal to r. All right, guys, so what I'm going to do is I'm going to combine these using the butterfly method. This denominator here is a 1, okay? So I use the butterfly method, multiply these two. P times 1 is P. 1 times A is A. P times 1 is P. And then what am I doing? I'm subtracting. And then now I need to multiply that by 1 over T. So if all of this multiplied by 1, anything times 1 stays the same. And P times T is PT. All right, so that would be my result, okay? So it says that we need to explain the algebraic error. I think the algebraic error was that here they distributed, but they incorrectly distributed. So they incorrectly, all right, distributed, okay? And it says what can be done to the answer to produce this as a result, okay? Well, technically what you could do with your answer is that you could write this, in reality I think this is the final answer. So again, that's the final answer.